All right, hi everyone, and welcome to this talk about infrastructure drift. Thank you for attending HashiTalks 2021. Well, our team loved GitOps so much that last year we initially built a complete platform to support infrastructure as code. And at some point, we started to look for feedback to build the next features. So we interviewed our users. And basically, our users told us that they were experiencing drift, that the problem was the drift. So we wondered if they were alone or not. And basically, we asked others. We asked CTOs, DevOps, SREs, etc., hundreds of them, and they answered basically a very similar thing. So we gathered all the answers in a single report. Basically, what everyone we talked to told us was that they experienced infrastructure drift recently. So in the end, that's the reason why we built this open source tool called Drift Control, driftctl, to help. So why is drift happening? According to the people we interviewed, three main reasons that we'll detail in a couple of minutes. The first one is that even the most advanced teams did not automate everything, or when they thought it did, it was only for one cloud, a single cloud like AWS, and then there was GitHub or GCP, Azure, anything else with an API as well, and it wasn't automated. The second main reason for drift to happen is with microservices, lambdas. They are all authenticated now, and sometimes things go wrong. So the third and final reason for drift to happen is around customers, management. Those people tend to have their own admin credentials. And well, guess what? Sometimes they use them, so problems ensue. So I'm Stefan Jordan. As Jordan pretty much everywhere on the internet. I've been around web infrastructures for the past 20 years. I co-founded a bunch of companies in Canada and Europe. Many years ago, I wrote this book, Infrastructure as Code Cookbook, for Pact, and more recently, I am the happy co-founder of the open source tool Drift Control with a wonderful team. So, as I said, we talked to hundreds of people, and mostly everyone had the same definition of drift. And this definition is what happens when the reality and the expectations don't match. It's also known as, oh my God, when things go wrong when they should not. So people told us about the main causes of the drift they experienced. And nearly everyone experienced it because of manual changes. So what a manual change? It's when someone goes to the web console, AWS console, and create resources, update stuff, changes the configuration, that kind of things outside of Terraform. So that's a manual change. And authenticated applications for half of the responded. Basically what they mean is, microservices that are supposed to only read something somewhere or write buckets here, and then it goes wrong because of a bug or something. And the third and final main cause of drift is out of sync environments. And at the beginning, initially, I thought it was about promotion. People had issue promoting, staging to production, but it was in fact about false positives, hidden, unseen changes from environment to environment, and sometimes changes from weeks ago. It's when things work pretty well in the first environment, all the tests are okay, etc. It gets promoted to environment number 2, but there it doesn't work, because if it was working on the first one, it's only because something else was there, like a security group rule, some parameter somewhere, something not on Terraform. IAM policies, roles, etc. Were reported very often as well. So we asked those people how often it happened, how bad it actually was, how long it took to fix, usually, that kind of things. And thankfully, very few people experienced drift on a daily basis. Can you imagine? Fixing drifts every day. But nearly half of them experienced drift like once a week, more or less. But 41% of them, it was like once a month. This is major because more than half of the people we interviewed told us it was usually taking multiple hours to fix, like from 1 hour to half a day. And that's huge. Even more if we had the third of people losing 1 hour every week or 2 weeks to fix the drifts, big drifts, small drifts. But most of those drifts were just mostly toil, adding toil every time. Things that should be fixed by automation, things that had no value by themselves, just purely lost time. But also, nearly 20% of those drifts ended up being security issues, like open ports, forgotten vulnerable VMs, lost subnets, bad policies. So it's not minor issues we're talking about here. So we asked the same people what they did about it, because we're a population, like we love tools, we love fixing problems, we made it a way of life. So basically what they told us was 2 main areas of solution. The first one is clearly about locking down all accesses, staging, production, both, removing credentials for everyone, but unfortunately not more often than not really everyone. We'll see in the second part of this talk with the stories how things went. And the second area of solutions is more around workflows and processes. Ranges from having commands like Terraform plan or similar tooling in a cron job or in CI to full-fledged GitOps workflow, checking pull requests, executing tests, having linters, etc. So all the solutions are cool and useful at some point, but none was really useful at making drift visible to the users. So many people also mentioned limitations, like sometimes things are complicated in older environments. You cannot always install everything you want the way you want it. Or Terraform plan, not being aware of what's outside of its scope, which is by design, and it's totally normal. And very often as well, the complexity of removing all credentials to people, there is always this special person that needs special access for some reason. So sadly, all the solutions found by the people we interviewed were defeated in the end, either because automation wasn't total, Either authenticated applications went wrong at some point, or admin credentials were still in use. So basically, drift still happened, and people were often not aware of it. So it's time now for the stories. I'm gonna share like 3 of them. They are simplified for the talk, otherwise it would take hours of context and examples. So they are here to illustrate the point. And they are straight from the people we interviewed. And I mixed in how our own open source answer helped. So this is the very first story. It's about a Lambda with read-only access. So it's authenticated. There is a key. There is an attachment for a read-only here, read-only policy managed by AWS, etc. And the team deploys it on Friday, new version. And during the weekend, for some reason, it stops working. There is an outage, and the on-call team during that weekend didn't know where to start, and basically they tried many things, and they wondered if it wasn't maybe an issue with authentication or the rights, the access rights. So they started, they went to the web console and they said, okay, let's rotate the keys. So they deactivated the old one, the one in Terraform. They created a new one. Didn't change anything, wasn't the culprit. So they went to the permissions, said, oh, read-only access, maybe it's not enough. So sorry, it's not our access advisor. Sorry, add permissions. All right, administrative access. So they added a large policy to this Lambda. We waited a couple of minutes, they had a coffee, went back, and it was working again. It wasn't probably even related, but now they were happy about the situation. The problem was solved for them. And they said, okay, we will anyway report it back on Monday. So, what happened on the team pipeline on Monday? As you remember, there is an IAM user, there is an access key, and there is a policy attachment, read-only. So they have this similar Terraform apply, plan and apply on CI, and every hour or so it's running. But on Monday, nothing was reported. Exactly like this. 0 added, 0 changed, 0 destroyed. But still, we added permissions, we deactivated a key, and we created a new one. And basically, this team didn't know that a new key is a new object for Terraform. They didn't know that adding a permission, attaching a permission to an IAM user is basically a different resource, and hence out of current Terraform scope. So Terraform plan and apply cannot see about, cannot know about it, cannot report about it. It's not its job in this case. So if they had, it was perfectly normal. So if they had drift control, so you can just drift control scan, fit it with the states from the IAM, VPC, and S3 for our current stories. They would have seen that the user EAA6FV has a new access key, and they would have seen that the administrator access policy was added to this user. The coverage was done from 100% to 75%, and two resources were not covered by infrastructure as code, Terraform in this case. So if they had drift control in their toolbox, they would have known about this change right away. But unfortunately, it stayed that way for a very long time in their case, because it was only by pure chance that someone was looking around and found out that this key, this IAM user, had a rogue IAM key running, and a policy that was definitely not read-only. So terrible on the security side. The second story is like at the beginning of the pandemic, people were starting to work from home. It was sometimes not very well organized. Not everybody was ready for it. And so it was working for many people in this team, but for a couple of people it didn't. They couldn't connect to the company network. And they didn't want to wait for IT to solve the issue. They got angry, impatient, and they asked some managers to do something. And it happened that one of them had enough credentials to basically open up everything to everyone. So our Terraform in this case here is a security group, a resource, and they had rules as separate resources that were linked to the security group resource. There is different ways to build security groups in Terraform with inline rules, etc. But in their case, that's how they did it, and they did it massively like this. So how does it look like? What our manager did. So we have a super secure AWS security group resource. It's here. So let's go there. It's SSH 22 TCP, allowed only on the local network. So now our manager says, okay, my team needs to work. I don't have the time. It's Friday night. Let's allow all traffic from anywhere, IPv6, IPv4, I don't care, and let's call it temp. Save. Guys, does it work? Yes. All right. So our manager, pretty happy his team could work. Now, our team, they were not new guys. They had everything on Terraform. So what happened? Do you think happened in this case? Security group with a rule? Nothing. Creating a new rule directly on the web console for Terraform, for AWS. In the case of Terraform, it's a new object as well. So it's not seen by Terraform plan, Terraform apply. So drift control in this case does the same thing. It takes all the states, compares to the structure returned by AWS API. And here we have the security group rules that were just created by our top manager. So the security group, protocol, the ports, IPv4, the IPv6, and the coverage is down from 75% to 60%, and 4 are now not covered by infrastructure as code. So basically, this team missed an open security group for weeks. For weeks, the main security group stayed fully open to the world, and nobody noticed it. Just because they relied on their pipelines and that drift was not something they took care of, and they just discovered it by chance by looking around once again on the AWS console. So our third and final story. I like this one because it's a cool team in London. There are like 100 developers. They build a plugin for like an enterprise plugin, and every hour or so, the build for each of the developer is uploaded to S3. So, and there some analysis is done, QA, etc. So they get feedback very quickly. So it's a lot of gigabytes every day that is uploaded on this S3 bucket and deleted. And one day, another team from another continent, they went to them and told them that they were working on improving compliance and security in the company, and they were doing a lot of things, including activating S3 object versioning for every single bucket. So the team in London said, well, cool, it's a good thing to do, you're right. But in our case, this very specific bucket, it's really useless because it's going to cost a lot for nothing because, well, it's just garbage, just trash. We upload things, we test them, and we throw them away. And the other team said, oh, cool, thanks for telling us. We will not include your bucket in the program. Sorry. We will not include your bucket in the program. So they went home. Our team in London said, okay, we have anyway all our S3 buckets in Terraform. So if something changes, we will know about it. And the other team started to work on it. They created a wonderful script using the AWS CLI with a lot of things, including exclusions for the 2 or 3 buckets that were not to be versioned. And it executed flawlessly without errors. And basically, everyone was happy. Until the first week of the next month when they received the bill, because basically, let me show you the console, what happens when you enable versioning. Okay, it's done for the HashiCorp demo EAA6FV bucket. And now they had all the buckets on S3. If they had launched drift control at that time, they would have seen that there was a drifted resource here. The HashiCorp demo blah 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 went from false to true, but once again, unfortunately, as the default was not set on the resource, basically Terraform did not return the change, and the change so was detected by this highly efficient monitoring tool called the billing finance department. They were not happy about it. That's the monitoring alert that costs hundreds or thousands of dollars. So basically, what we talked about is drift control. We created this open source solution in Go. It's released as an Apache 2 license. We have AWS and GitHub support, means that if you manage your Git repos, teams, memberships using Terraform, we do detect drifts the very same way that we just showed using AWS. We have Terraform state support for local states, S3 states, HTTP backends, authenticated or not. Even if you have thousands, hundreds, billions of states, it should work. We have very cool filtering. So you can manipulate the output pretty much the way you want, including a quite cool ignoring, as like if you know the git ignore file, it's very similar. It's like the drift ignore file. So it's cool. So it's all available on GitHub, cloudskift/driftctl. We are all day long and most of the nights on Discord. So it's driftcontrolled, driftctl.com/d. It will redirect you to the right Discord channel. For every single release, we do a live stream on Twitch and on YouTube Live. So it's the very same channel. Go to Discord, you get all the information. Go to our Twitter, Drift Control, as well. So it's all there. Come talk to us. Give us feedback, how you use the tool, how it's useful or not. What do you miss? Do you integrate it on CI and how, etc. The report I mentioned at the beginning of this talk is available from driftcontrol.com. It has a lot of very nice infographics. So yeah, it's available on driftcontrol.com. Obviously, it's free. And so yeah, so if you joined during the talk, what's to remember basically is that almost everyone has experienced infrastructure drift recently because of manual stuff, authenticated applications, etc. And that we built Drift Control to help to complement Terraform in your DevOps toolbox. So thanks for watching, and hopefully now some Q&A. Thank you. See you soon. Bye-bye.